Every single Thursday, Rohan, my local garbage man, comes to my neighborhood and collects our trash. He even leaves a few funny comments like, "You're late to school again, aren't you?" Or, "Focus in school, don't do drugs." Something funny like that. And if next Thursday he didn't arrive and I didn't get to see him, I'd be super disappointed. Because one, he wouldn't be saying all these funny comments, but second, my house would be a wasteland. It would be stinky, and I wouldn't want that. So I've developed a great appreciation for Rohan. And this led me to think about all the garbage that we have here on Earth, all the trash and accumulative. And specifically, the trash that we have in space, in orbit. Right now, we have 128 particles of junk that is bigger than 1 millimeter. Those are the ones that we can track right now. And this number is only going to increase with the amount of increase that we have with satellites being launched right now. Because currently, we see that since 2005, we've had a steady increase of satellite launches. And this is because private companies like SpaceX and Amazon see so much potential in satellites, because satellites give us data. And in the future, what SpaceX is planning on doing is to launch about 50,000 satellites up there in space to get global coverage of internet. And so that's kind of wild. But all this hype, not supposed to say sorry. So all this hype with the increase of spacecrafts being launched there in orbit, so does the increase of fragmented debris. So what this just means is that we had an existing satellite that was functional, and then it just broke into pieces. That's debris. That's total pure crap. And it makes sense why we have such an increase in satellites and people are using it. The hype makes sense because it provides us access to data in many different industries. But specifically, what's really important is data for environmental purposes. We get to track the biodiversity of a specific country. Not sure what country that is, thought it was Italy, but it's not. But also we get to track the ice caps melting in the Arctic. All of this information is extremely important in deciding how we can tackle the climate change issue. It's just data is important, satellites give us data, I understand the hype. But furthermore, since all these private companies and governments see the hype of data, their incentive is to purely launch that satellite up into space. But the incentive to take these satellites down are weak. And so this mix-match of incentives is actually really detrimental towards our space junk debris problem. Because as the more satellites that we launch in orbit, the more dangerous it becomes, because we have these objects moving at high velocities with ability to collide with each other and create even more junk. And so we're in an environment where that orbit can be so dangerous that it poses potential threat to current and future spacecrafts. That's not good. And I like to think about this idea of mixed match of incentive through a more relatable type of analogy, given that I go to Starbucks every single Saturday and I order a latte. I love lattes because I'm just focused in tunnel vision on that result. I'm not really thinking about the consequences of where that junk ends up. That's exactly what's happening with these private companies. They're just focused on the result, but no one really wants to take responsibility for the consequences of space debris. But it's not just spacecraft itself. There's also another problem that this poses potential threat to. That being our sustainable travel. How we can develop a multi-planetary system in which we can go to Mars and go to different planets. But this isn't possible if our orbit becomes so dangerous that we can't even leave it. So multi-billion-dollar projects out the window, right? We can't really invest in further space exploration if our orbit becomes dangerous. And so all of this is further intensified with the Kessler syndrome. So what the Kessler syndrome is it's just 1 to 2 objects colliding with each other, creating even more space debris, and this increases the potential of more collision to happen. But what's really important to note is that as more collisions happen, that shortens the amount of time for the next collision to happen. So it's this chain reaction that's really time sensitive. And to put this into perspective of what I've just said, is a summary, this equation summarizes us all. So we have this element of it compounding artificially. us as humans, we see value in satellites, so we launch it up there. That's artificial compound of space debris. But there's also a natural element to it. If we didn't launch a single satellite tomorrow, this amount of space debris would still increase because of aerodynamic drag. When we have a spacecraft in orbit, it'll only break down into even smaller pieces because of that drag. But furthermore, collisions. So it's going to happen either way. Our solution can't just be, let's not launch satellites. That's not really feasible. But saying that, that part about it compounding artificially is super important because we still want the benefits that satellites give us. And so can't really change that equation. So what do? We add another element to it. What we can do is implement an active debris removal method in which we actively launch these satellites to combat our space debris problem. And so there are essentially two ways in achieving this. We have a contact method, but also a contactless method. Not contact list, but no contact method. And so with a contact method, it looks like a harpoon shooting at a net. A harpoon with a net shooting at an object to collect it and bring it down to Earth. But this has a lot of problems and barriers that you have to overcome. It's like a school bus flying wildly in orbit and you trying to capture it and not move with it wildly. It's just really complex and there's a lot of barriers to it. So what's actually more feasible is a contactless solution through ion beam thrusters. This technology currently exists right now, and basically what's happening is that we have ions that are being ejected through that thruster, and which is moving in high velocities, so it can push that wildly moving school bus out of the way, deorbit it, and it falls through the atmosphere, burning. As it falls through the atmosphere, it burns. And this doesn't really have much impacts of us here on Earth. As it burns through the atmosphere, we're not necessarily we're not going to see a flying school bus come down to us here on Earth. It burns in the atmosphere and stays like that. So essentially, what's happening with the Ion Beam Shepard is that we have a satellite that it's called the Shepard, and it has two propulsion systems. The main propulsion system is using the ion beam to hit that target so it can move out of orbit, so it enters that atmosphere so it can burn. But there's another propulsion system, that being it's just trying to compensate for that propulsion we've hit with that ion beam. It's just Newton's third law, where with every reaction we have an opposite reaction. We just want to ground our satellite so it doesn't move like a rocket out into a different orbit. And so essentially, I've talked about the ion thruster. It's actually pretty feasible. We've had previous launches using this technology right now, and it actually travels at 9 kilometers per hour, and it has a 90% efficiency. Super, super important tech, and we can use it. So when we talk about the advantages of the Ion Beam Shepard, it actually uses current technologies that's being used in the space industry right now, but also it simplifies that equation of it being a contactless method. That's super cool. So what's stopping us from implementing this tech? Well, essentially it just comes down to people realizing the urgency of this issue. I emailed the research paper author who talked about the ion beam thruster, and I asked him, why are all the research papers about this in 2010, 2011? Why are there no hype left? Why is there no hype left? And he was like, well, the ESA, European Space Station, we're waiting for a major collision to happen so we can have funding in this project. So they're literally waiting for a major collision to happen, major catastrophic thing, and then they try to come up with a solution to tackle it. It's kind of a reactive situation type problem solving idea. It really doesn't make sense. So we're waiting until it becomes serious enough to have a problem. Really doesn't make sense. But another part of it is funding. When we don't see the urgency in a problem, we don't really want to fund it. We don't want to invest that project in it. And so if we can overcome these two barriers of seeing the urgency in it, but also funding that project further into its feasibility, okay, yes, you understand what I was trying to say. We're actually able to complete this equation and have that active debris removal operation. We're able to have our Rohan in space. we're able to have that waste management system in which we can keep the growth of satellites and achieve that benefits that we get from it, being data. But also, we can compromise and avoid the catastrophic events that would occur if we ignored this problem, it being a threat to a problem. So essentially, if we're able to move forward with the ion beam thruster, we can develop our space industry to be sustainable. That's super important moving forward. Thank you.